Okay, well, I hope you guys are doing okay in your other classes. I hope you guys feel like you're doing okay in this class. Um, I've posted more practice problems. Okay, so if you haven't seen it already, this is the practice final. I'm biased, but I feel like the practice final is representative of the actual final. I mean, that's my intention, is to give you a a test that that is representative of what you will see in the actual final. Okay. The only thing that isn't really in the practice final that's on the final is some conceptual questions, and so anyway, we have the practice final answers here, and they should go over that. I've also added some practice problems for chapter 9 and some conceptual practice problems. We have a question here.
How many problems from like the first and second semester?
How many? Okay, yeah. So the question is basically, how cumulative is the exam? So there are going to be a handful of questions. Maybe about 15 to 20% of the test will be definition or conceptual questions from chapters 1 through 6. Okay, so they will not be calculation based in nature. So you will not have to calculate, the probability of B given A, or you won't have to calculate, a binomial probability or something like that. But you'll have some definition-based or conceptual-based questions from chapters 1 through 6. Something like, I'm just pulling something off the top of my head here. I don't know, what numeric summaries can be used to measure spread? Okay, and you would tell me that the standard deviation, the IQR, things like that can be used to measure spread, or something in that vein. So they're mostly definition or conceptual based in nature. Okay, here are some chapter 9 practice problems with some multiple choice answers, and also some conceptual practice problems with multiple choice answers. Okay. As far as the practice final goes, the biggest difference between the practice final and the actual final exam is that the actual final exam will be multiple choice. And because it's multiple choice, sometimes that throws off students, because some of the wrong answer choices will be, you've done most of the problem, but you didn't finish. Okay, so it'll be an answer, where you've done half of the problem or something like that. Okay, and so my encouragement not to get trapped by those questions would be, finish out the problem yourself, and then after you finish the problem, see if your answer matches one of the answer choices. Okay, don't just do a few steps and say, oh, this number matches, therefore I'm going to select that. Okay. So the actual final is multiple choice. Don't let that mess things up. Here are some conceptual practice problems that you can go through. I thought today we would spend our lecture time covering more conceptual stuff, because I feel like, as far as the calculations go, I feel like a lot of you, for the most part, have a handle on it. And I feel like I've given you a generous amount of practice regarding the calculation-based questions. If you have any calculation-based questions, I'm happy to try to field those as well. All right, and then the answer to the chapter 9 conceptual problems are provided right here, so you can take a look there. Okay, are there any questions before we get into the content? Yes.
So you said for the first half of the questions are going to be conceptual. For the second half, is it going to be more mathematical or conceptual?
Yeah. So So there's going to be somewhere between 50 to 60 questions on the final exam. Probably like the first 10 will be conceptual based on chapters 7, 8, and 9. Okay, the first 10 questions will be there. Then you'll have these are just rough numbers here. Don't hold me to this, okay? So you'll have about 10 questions conceptual in nature from chapters 7, 8, and 9. Then you'll probably have maybe 5 questions or so that ask you to check conditions, okay? And then probably like 30 questions where that are kind of like the practice final questions where I give you a scenario and then I have 4 questions related to it where you calculate a p-value or a test statistic or standard error or make a conclusion, things like that. Or identify type 1 or type 2 error. And then probably at the end you'll have another 5 to 10 questions where I ask you, kind of definition-based questions on the from chapters 1 through 6. Okay, definition or conceptual questions from chapters 1 through 6. So something kind of like that. There will be a few bonus questions, so you can get over 100% on the final exam. And I think that's what we've got. Okay. Here's a little comic, or I don't know if you can call it a comic. It's a little humorous picture that I came across online. I thought it was kind of funny, but I don't know. Maybe it's not that funny. Okay, so this is an explanation of type 1 and type 2 error. This is a man, and the doctor says you're pregnant. Here's a woman who's obviously pregnant, and the doctor says you're not pregnant. So this would be the type 1 error, the false positive. This is the type 2 error, the false negative. Okay, and in this case, the null hypothesis is the patient is not pregnant. That's kind of what we assume in general, right? When you encounter someone, your assumption should be that you are not that person is not pregnant, and then and only if there's a great amount of evidence pointing to the contrary would you might make the assertion that someone is pregnant, right? But there are also social rules about not asking if somebody is pregnant unless that information has been shared with you. So anyway, that's week 10. Type 1, type 2 error. Okay. All right. Well, it gave me a sensible chuckle. All right. Well, let's take a look. Here are some practice questions here. So I'll just I'll put these in our notes, and then we can see. All right. So the thing here is we're trying to. Here's just a few problems where we try to identify the scenario. Meaning, is it, are we dealing with proportions versus means? Or are we dealing with one sample or two? Okay. There's nothing here about hypothesis tests or confidence intervals yet, so you can't answer that. Okay. So what do we have here? It says a researcher wants to know if the rate of teen pregnancy has changed. In 1995, the rate was found to be 8% of, I guess, teens get pregnant. And then a recent study surveyed 12,000 randomly selected female teenagers and found that 103 of them had teen pregnancies. Okay, what situation is this? We are dealing with proportions or means? Proportions, right? Because how do we know? Our data is provided as a count. This is a count, okay? And so, if we're given a count, then we're dealing with a categorical variable, right? Having a teen pregnancy, that is a categorical variable. So again, proportions. Okay. And then do we have one sample or two samples? Just one sample, right? This is our n. We've got one sample. Okay. Here, the next one we'll make a clicker question. Okay, and then and again we'll say proportions one sample, proportions two samples, means one sample, means two samples. Okay, and here is your Are you guys, is this text large enough for you guys to read? Yeah, kind of.
A little bigger than that.
A little bit bigger, please. Okay. Sure. I don't know. This is. Okay. So we'll get the thing going. Okay. A teacher wishes to know if the performance of his students has changed between quarters. Last quarter there were 150 students in his class. The average grade was 87%, standard deviation of 12%. This quarter he has 160 students. The average grade is 90%, with a standard deviation of 10%. All right, go ahead and click away. Oh, sorry. Week 10, Wednesday. All right. Okay, keep. Okay. Anybody still need to click? Get your clicks in. I'll end it at 1 minute here. Okay, so we'll click stop here, and let's see. All right. So as we're going through, we see 150 students. So this could be our sample 1, and we have 160 students. That's sample 2. Okay. So we're going to be dealing with two samples, and the question is, are we dealing with a mean or a proportion? Okay. Well, the key here is that we're given a standard deviation. So the standard deviation is a good indicator that we are dealing with a numeric variable. Okay, meaning that we would be dealing with means. All right. You might, and we also see the word average. Okay, average here, also an indicator that we're dealing with means. Okay, and you might say like, well, I see a percentage. Doesn't that mean I'm dealing with a proportion? Okay. A lot of times percentages are proportions. However, here we're looking at the numeric variable, which is a kind of a score, okay? And so the score is calculated as often as a percentage, but you can think of that as kind of like the unit used to express your grade, right? So your grade is a numeric variable between 0 and 100%, and you can kind of think of that percent as the unit in which our grades are expressed, okay? It's not that this 87% isn't the proportion of something, okay? It's not a categorical variable that we're representing. It's a numeric variable that we are looking at. So here we are dealing with means, and we've got two samples. Okay, so I think the biggest hints here, though, is that it says average grade, and you also see a standard deviation. All right, we'll keep clicking along here, and I'm just going to bombard you with a bunch of these questions, and we'll go through them. Okay, so it says you create a 95% confidence interval for mu, and the interval goes from 1.2 to 3.5, and then I give you some true-false questions about which of these statements are true or false. I guess you can just kind of write notes to yourself about true false statement 1, 2, or 3 to kind of just decide here. And I'll give you guys a minute to decide here, or maybe not that long. You can discuss with your neighbors about which ones are true and which ones are false. I won't bother with the clicker right now. We'll have enough questions to have enough clicker questions to fill out our day here, but just not right now. So. Okay. You guys good? I don't know. I didn't hear as much discussion, but maybe these questions are easy. Okay. All right. So the answers are. First one is what? True. The first one's true. The second one is false, and the third one is false. Okay. At least that's what I've written down. Let me just double check here. Okay, so we created a confidence interval for mu, so we're dealing with means, okay? And the interval goes from 1.2 to 3.5. Our confidence interval provides evidence that the population mean is not 0. That is true because 0 is not inside our interval. Okay, so this means we do have evidence that the population mean, so this thing, population mean, that's mu, that mu does not equal 0, okay? And in fact, we have evidence that mu is greater than 0, if we wanted to point that out. Okay? Is it possible that mu is 0? It is possible. What would have had to have happened, though, for mu to be 0? So it is possible that mu is 0, and then that we just got some really bizarre data that leads us to the conclusion that mu is not 0. Okay, but it is possible because if everything is random, right? It's technically possible, right? If you have an infinite number of monkeys typing away, like it is possible, and actually with infinite, guaranteed that one of them will type out the works of Shakespeare, but highly unlikely, right? Okay. Well, with infinity, everything breaks, but okay. Our confidence interval provides evidence that the population mean is not 2.5, okay? So here we have 2.5 is inside the interval. Okay, so 2.5 is a plausible value for mu, and we cannot or we do not have evidence that it is not 2.5. Okay, and then lastly, our confidence interval provides evidence that the population mean mu is equal to 2.5. Confidence intervals never say that mu equals something. Okay, the only time we can say mu is equal to some value is if we actually look at the entire population. And in general, the population is too big for us to do at a practical level. Good? Well, I guess the hope of this session is that either it will give you confidence in your knowledge, your current knowledge, or it will reveal areas in which we need to review. Okay. Okay. All of these ones, what do we say? So same thing, we've got confidence interval for mu, and then the question is, are any of these statements true? There's a 95% probability that the population mean is between here and here. What's the answer there? False, right? We never talk about probability, okay? CIs are not about probability. Okay, mu is a fixed but is unknown but fixed. Okay, there's no uncertainty about mu, so we can't talk about probability. It's like the coin flip that has happened but you haven't seen. There's no probability associated with it. We just don't know, so we can only make statements about confidence. Okay, 95% of the values in the population are between here and here. True or false? False, okay? The confidence interval is always about the population mean or the population parameter. Confidence interval is always about the parameter. So that would be mu or p, and it's never about values about in the population. Okay, 95% of the samples will have sample means between 1.2 and 3.5. Also false. Okay, the confidence interval, I can just write the same sentence. The confidence interval is always about the parameter, and it's not about sample means. Okay, CI is not about sample means either. Okay, let me copy this one though, and if 100 samples were drawn from the population and each sample produced a 95% confidence interval, we would expect 95% of those confidence intervals to capture the true population mean. Does this statement even make sense? Maybe, maybe not. So this statement is true. Okay, so let me just kind of we'll break this down. What happened here? Okay, this is the meaning of the 95% when we talk about a 95% confidence interval. Is that when you make a confidence interval based on kind of the mathematics behind making that interval, the way we've determined our margin of error, is that when we draw a random sample and make this interval, 95% of the intervals that we make will capture the population mean. Okay? And so, that feels like, well, if that's true, then why isn't this statement true? Okay? The 95% probability that the population mean is between here and here. Okay? So over here, this top statement is not true because it's talking about a probability about mu. Is mu between some particular set of values? The answer is either going to be yes or no. We just don't know that answer. We're 95% confident that it is, but we don't know the answer. Over here, there is a random element. The random element is this sampling process, okay? So here, this is the random part, the random sample. And so what we're saying is that when we draw a random sample, there's basically a 95% probability of getting a random sample that leads us to the right conclusion, okay? But because it's random, there's also a 5% probability that the sample leads us to the wrong conclusion, okay? It's about the sampling process. That's what this is talking about. Once you've created your interval, then your interval is fixed. Mu is an unknown but fixed value. There's no more probability there, okay? However, when we're talking about drawing a random sample, there is uncertainty about the sample that we're going to draw. And that's what this is saying. If we draw 100 random samples from the population and each sample makes a confidence interval, we expect 95% of those confidence intervals to capture the true population mean. Does that make sense? Okay, some of you are nodding and others of you, I'm having a hard time reading. Yes, question?
Can you explain that one more time?
Can I explain that one more time? Yeah, absolutely. So I'll try to do it as clearly, but also as briefly as possible. When we take a random sample, okay, when we then make a confidence interval, okay, and that confidence interval either manages to capture the true population mean or it doesn't, okay? However, when we take a random sample, we might get, quote, good random samples where the confidence interval is correct, or we could also get a bad random sample where the confidence interval is wrong, okay? When we do a 95% confidence interval, we've done it in such a way that about 95% of our samples should be good, okay? When we do random sampling, 95% of them should be, quote, good samples that lead us to confidence intervals that give us the right conclusion, okay? However, there's always a possibility that we did something wrong, okay? So if we did 100 of these samples, we would expect about 95% of those samples to be, quote, good, and those good samples would produce confidence intervals that capture the true population mean. Is that better? Okay. All right, so we've got, all right, so this statement is true. I've said a lot. I don't know if I can just write it down in one sentence here. You can listen to the audio and the video. Okay, let's keep going through these questions here. All right, so here it says you perform a hypothesis test to see if the proportion who like Vitamita Vegemin, that's from I Love Lucy, right? I don't know if you guys, is that even still on TV at all? Maybe, who knows? Okay, it's a classic. All right. Okay, so we want to know if the proportion of people who like Vitamita Vegemin is less than 75%, okay? And the p-value for this test is 0.01, and we used an alpha of 0.05. Okay, which statement is true? We'll do a clicker question here. Let me okay, I'm hoping you all can see and read this. Well, you can turn to your neighbor and discuss if you need to. Okay, I mean, so if you're not sure, you should try to figure out what your null and alternative hypotheses are. Okay, and then decide if you're. All right, I'm gonna go click stop in a few seconds here, so get your clicks in. Go click, click, click. Okay, I'm gonna hit stop here. All right, let's go through our choices here. Okay, so when we set up our hypotheses, okay, we're looking at the proportion of people. So it's going to be P. The null hypothesis always has an equal sign. And then the alternative looks just like the null, except it's got a different sign. So in this case, the proportion that we're looking at is 0.75. So here our P is going to be 0.75. And then the alternative says is less, right? So the test that we're doing wants to see if P is less than 0.75. So these here are our null hypothesis, okay? And then we got our p-value is equal to 0.01, and we're using alpha equal to 0.05. Therefore, our p-value is less than alpha. This means we do what? We reject the null. Okay? So we've rejected the null, and we're going to say we have evidence that this is not true, and therefore we have evidence that this is true. So we reject the null, and we say we have evidence to support the alternative, right? We've rejected the null. We're going to go with the alternative. What does our alternative say? Our alternative says that the proportion is less than 0.75, okay? So we have evidence to say the proportion is less than 0.75. That's going to be answer choice C, okay? We would never say A, okay? We have evidence. We would never say we have evidence to support the null, okay? And then we don't say D. If the p-value was bigger than alpha, then we would go with B, but it's smaller than alpha, so we reject that. So our answer choice here is C. Okay? So our p-value is less than alpha, therefore we reject the null hypothesis. Is that okay? All right. Here's a very similar question, but I'll just put this. We won't make a question out of it. We will not clicker this question, but here, okay, same setup. Which statement is true? And in this one, it is C. We have evidence to support the alternative. Okay, so the p-value is less than alpha. This means we reject the null, and we have evidence to support support the null. Okay. We would never say we have evidence to support the null. This will be a never. Okay. We do not have evidence to support the null. We would never say this either. Okay. This is not true either. Okay. And so either our conclusions, this happens if the p-value is less than alpha, and then this is true if the p-value is greater than alpha. Okay. So these are all words using statements using the word support. Okay. These all kind of sound similar, but so these would never be true. This one is true if the p-value is less than alpha, and this one is true if the p-value is greater than alpha. Okay. So these are all statements using the word support. Let me throw up some statements that use the word reject. Okay. So these are all the reject statements. Okay, same setup. Okay, the p-value is less than alpha, right? So this means we reject the null. Okay. All right, and so in this case, which statement is true? We would say we have evidence to reject the null. Okay. And so this would be true if the p-value is less than alpha. And then this one is true if the p-value is greater than alpha. Okay? These ones are never true. You have evidence to reject the null. This is never. And then you do not have evidence to reject the null, or the alternative, I'm sorry. These are never true. Okay? So statements about rejection always line up with the null hypothesis. Statements about supporting or accepting line up with the alternative. Okay? We don't talk about accepting the null. We don't talk about rejecting the alternative. So, so that's kind of how our conclusion statements line up. Okay, are there any questions here? All right. Okay, let's go through, do a few more of these. Okay. Whoops. All right, so we're going to do a hypothesis test to see if the proportion of North Campus students who read novels for pleasure is greater than the proportion of South Campus students who read novels for pleasure. All right. All right. So how should we set up our hypotheses? Okay, I guess we'll do a last clicker question. I think this one's pretty straightforward, but okay. And then this exclamation equals. This is just because here. I guess I can fill it in with not equal signs. It's just I didn't feel like looking up the special character code in Word to get this symbol. Okay. So read through the problem and then decide what the appropriate hypotheses are. Okay, just a few more seconds. This one seems like it's I think this one's easy. Okay, so I'm going to go ahead and click stop here. So if you haven't clicked, go ahead and click. Okay, so our first rule is that the null hypothesis always has an equal sign, right? So right off the bat, we can eliminate answer choice B and we can eliminate answer choice D. Okay, and then here, oops. The key word here is we want to see if the proportion of North Campus students who read novels for pleasure is greater than the proportion of South Campus students, okay? And so we will go with answer choice C, okay? And based on this, apparently P1 means North Campus, and P2 will be for South Campus, right? If there were an answer choice such as P1 is equal to P2, and then the alternative was that P1 is less than P2, this would be ambiguous because based on the statement of the problem, we haven't identified which group is group 1 and which one is group 2. Okay, so I wouldn't do this to you. I would either, in the problem, I will say this is group 1 and this is group 2, okay, to make it clear, or I'll only have one answer choice as far as the alternatives go. Yeah.
When in cases will I ever use A?
If this said, if it was different, okay, if we had, instead of greater, if we said, is the proportion who read novels for pleasure different from the proportion of South Campus majors who read novels for pleasure, then we would use answer choice A, okay? So this, we would, if it's a different or not the same or something that means not the same, not equal. So that we've got that. Okay, I think I've got one more of these. All right, last one for the day. Okay, and we'll say doctors can administer an STD test. The test would assume that the person is STD free unless they show symptoms of having a disease. The null hypothesis will be that the patient is disease free, and the alternative will be that the patient has an STD. Okay, so you want clickers or no clickers? No, okay, no clickers. All right, go ahead, talk to your neighbor, try to decide which of these is the correct answer choice here, okay? Is the type 1 or is the type 2 error worse? And do you then want a large alpha or a small alpha?
Type 1 error is the chance, alpha is the chance that you make a type 1 error. Right? So in order to decrease type 2 error, you have to make a sacrifice. I missed a question like this last time. That's why I might need
Okay, what do we say? Type 1 or type 2 error is worse? Type 2 error is worse, okay, so we'll eliminate answer choice 1, A and B. And then do we pick a large alpha or small alpha if the type 2 error is worse? Yeah, we would go with the large alpha, okay? So type 1 error, I mean, this sucks. This is a healthy person is diagnosed with a disease. Okay. But the type 2 error is someone has the disease but is told they're clean, no problem, and that could be produce some, epidemiological problems, right? So, a person with STD is told they are healthy. That's a problem. Okay? So, type 2 is worse than type 1.
It's all a matter.
Okay, we'll see you guys on Friday.